Hello everyone. Now this is the lecture we are going to see the concept of GSM. So GSM is nothing but the global system for mobile communication and having a specific objectives for good speech quality, ability to support handle terminals, low terminal and service cost. It also provides the efficiency or work on a spectral efficiency. Also, ISDN compatibility is provided with this global system for mobile communication. Okay, uh, we are going to see the details of the GSM system. Uh, this GSM system is totally based on the two types of combinations of frequencies and time division multiple access. Uh, FDMA is nothing but the frequency division multiple access in which frequency is distributed along with the number of channels having a specific range, and also it is provided on a specific duration of time. So it is the best suitable combination for a number of users which are connected in a single network. So its allocation is done with the 50 megahertz of frequency from minimum 890 or 915 megahertz to 935 to 960 megahertz, and having a bandwidth of the 900 megahertz frequency band. And by using FDMA, it is further divided into 124 channel, in which apart from this 124 channel, 124 are used for uh, users and one is not for user, which one is a reserve for the processing, and these 124 channel again having us distributed into a 200 kilohertz frequency. Okay, so the frequency is distributed, and also the by using the TDMA, the above channels are distributed along with the 8 time slots. Okay, so the frequency time, these number of frequencies are distributed along with the 8 time slots. Okay, so the combination of FDMA and TDMA creates 992 channels for transmit and receive over a network. Okay, how you are going to use the frequency? You know very well, if a specific call is completed, then that particular frequency is free for uh, or gets free. Okay, so at that time we are not going to avoid that frequency. We are going to use that frequency for another channel. Okay, it is called as a reuse. So there are hundreds and thousands of users. So that's why the frequency must be reused, and this is done through the cells. Okay, there are a number of users are there, so the frequency is reused and it is done with the cells. The area to be covered is subdivided into radio zones or cells. Consider a specific area which is having a specific zones. You can say that as a cells. Though in reality these cells could be of any shape, but for a modeling purpose, it is modeled as a hexagons. Okay, so base stations are positioned in the at the center of the cells, and each cell I receives a subset of frequency FBI from the total assigned set to the respective mobile network. And to avoid any type of co-channel interference, two neighboring cells never use the same frequency. We can see this cell structure over here. This is considered as a one area in which that area is distributed along with the four hexagonal cells. Okay, one, two, three, four are there. So, and one thing keep in mind, the two subsequent network or two network are not same network are not allied to each other. See over here, one and one having dispersed with the four. Okay, and there is a gap between the one and one. There is a gap between two and two. There is a gap between three and three. There is a gap between four and four. So Uh, the main purpose behind that is the same frequency which is used in channel 4 in this area, and the same frequency used in channel 4 in this area will not be merged to each other and will not be complex to each other. Okay, so d distance is maintained between the number of cells. Okay, and this whole combination is called as a cluster. The number of cells are come together, and it is called as a cluster. So k is equal to 4. That means each area having a 4 cluster cells. Okay, so as I said, told you that the two same frequencies are uh, having a distance of t with their procedure, and when moving from one cell to another, on ongoing conversation, an automatic channel occurs, and this is called as a handover. Handover means if you cross any boundary or any range of a cell, and it will pass it to the another network. So uh, the channel gets automatically changed, and this is called as a handover procedure. Okay, so this is about your cell cluster. You can draw this diagram in a simple manner, and you can just specify all the necessary details, that is distance, cluster, and value of your cells. So how this GSM hierarchy, the most important question we ask you. So consider a specific location or area in which there is a administrative region for your cellular network. So it is also called as the public land mobile network, that is PLMN, and GSM administrative region. एक हमारा BSNL चैनल की तरह होता है जहाँ पे मैं आप लोगों के एक्चुअल मेन स्टेशन जो बोलते हैं हम लोग उसको कंसिडर करेंगे. Okay, so this is one area having a specific region. The number of region area is distributed along with the mobile switching center, that is MSC regions. Okay, one area is there and having its sub regions. Okay, one center is there, you can consider PLMN, and this center associated with the number of sub regions is called as a mobile switching center. This mobile switching center having a specific location area again is distributed into location area MSC. The location area pointed to the MSC region, MSCs are pointing to the uh, PLMN region. Okay, so every location area having its own base station controller, that is BSC, and number of cells of users can connect it with the BSC. Okay, so it is base station controller for this local area. This is base station controller for this location area. There are number of location areas. There is each and every location area consists of your BSC. Okay, so this is your hierarchy works. You have to write all the details in a proper manner. Okay, the number of cells are connected to base station controller. Base station controllers belongs to the location area. Location area is pointing to the MSC region, and these all MSC regions are pointed to the GSM administrative region. That is the main source here. So this hierarchy consists of, as I told you, that one minimum one administrative region is assigned to one MSC. Yes, one administrative region is there for one MSC. The administrative region is called as a PLMN, that is Public Land Mobile Network. The administrative region divided into number of areas, that is location area, and each and every location area consists of a cell of group and assigned with the one BSC, that is base station controller. You can say that the towers, each BSC, there will be a BSC, one BSC, and number of cells belongs to that location area as connected to the base station controller. Okay, here is the architecture, most important part of your GSM system. So over here, see, these are the various entities which are belongs to GSM architecture, that is mobile station, base transceiver station, base station controller over here, OMC, that is operation and maintenance server, MSC, that is mobile switching center, VLR, visitor location register, HLR. VLR and HLR are the databases which is used to store the static data and dynamic data. For example, authentication center and equipment identity register, which is used to identify your mobile device systems and other things. Gateways are there for communication between the various cellular network and line or public switching telephone network. So gateways are useful over here. So this is all about your architecture. You can consider it as a just specify the mobile station BTS, BSC, mobile station BTS, BSC. The number of mobile station are connected to BTS, BTS are connected to BSC, BSCs are connected to MSC, MSCs are connected with the uh, overall all these necessary things which are responsible for maintaining and providing the number of resources or services to your mobile station. Okay, so you can draw this diagram also. Over here VLR is there, visitor location register is there, network switching center is there, network switching subsystem is there, authentication system is there, so MSC is there, BSC, BTS. So it is a diagrammatical or structure, and this is your architecture, block architecture. Okay, you can draw it. So these radios areas are covered by the base transceiver station or base transceiver controller. Number of BTS are controlled by the BSC. The traffic from mobile station is routed to MSC. ट्रैफिक जो होती है मोबाइल की हमारे मोबाइल स्टेशन से आने वाली वो MSC के थ्रू जाती है एंड द GMSC दैट इज गेटवे MSC इज यूज फॉर calls originating from fixed network or to the mobile network. Okay, for conversion of fixed network calls into mobile network calls. Okay. Various entities are there. Mobile station, as you know, mobile station means number of users handed the device, and it consists of a mobile equipment, that is a body, and a SIM card, that is a subscriber identity module. Then base station subsystem, which consists of a BTS and BSC. Network switching subsystem consists of a MSC, HLR, VLR, and EIR and authentication center. As I told you that MSC is a mobile switching center which is responsible for maintaining the calls between the number of stations. Home location register stored the various databases. Visitor location register store the dynamic addresses. If your mobile station moving from one location to another, then it will update dynamically. Authentication center provide the permissions to your mobile system to use the number of resources. OSS is there. OSS consists of a operation and maintenance server. As I told you, mobile station having a body as well as the GSM, and GSM installed in every GSM phone. SIM card is installed in every GSM phone and identifies the terminal. SIM card contains the one ID called as the International Mobile Subscriber Identity, which is used to identify the subscriber system. Base station subsystem is responsible for transmission and reception of your transaction, which is divided into two parts, that is BTS and BSC. Uh, it is responsible for transceiver and antennas used in each cell of the network. BTS consists of transceivers and antennas. BTS usually placed in the center of the cell and transmitting the power define the size of a cell. Again, base station controller is responsible for communication between the BTS and mobile switching center and manages the radio resources. Network and switching subsystem. NSS is responsible for providing the signaling functionality between the networks, between the number of networks. So it uses the signaling subsystem number 7, that is protocols are used for your signaling transmission. Again, home location register and VLR are databases which provide the routing and roaming capabilities of GSM. MSC does the following functions. like switching of your node from mobile subscriber of same network, connection between mobile phone to mobile phone within the same network. Second thing, it performs that switching node or connection between mobile phone to fixed phone. And the third is it performs as a switching node for ISDN integrated services digital network. Again, it provides the various functionality needed to handle mobile subscribers such as registration, authentication, location update, and also it includes the databases in order to store information to manage mobility of roaming subscriber. Okay, so it performs the network and switching task related to your mobile system or mobile network. Again, the two databases, I already told you that HLR is always fixed and stored in the home network, where VLR is logically moved with the subscriber. So HLR contains the corporate administrative information such as subscriber registration, and the VLR stored the signaling address associated with the mobile station. Okay. VLR contains selected administrative information borrowed from the HLR. जैसे हम लोगों ने बताया मैंने कि your subscriber उसका नाम address numbers the static data is stored with the HLR, but the moving addresses from one location to another and specific information is stored with the VLR system. The next component is a gateway MSC, that is GMSC, which is associated with the MSC and is responsible for converting the mobile cellular network or connecting the cellular network and PSTN, and also in charge of routing calls from fixed network towards the GSM user and vice versa. Okay, so this is all about your NSS subsystem. And next entity is the OSS. OSS controls and monitors the GSM system. It provides the different component of the NSS and to the BSC, and also in charge of controlling the traffic load from the BSS. Okay, it is NSS and BSS के BSC के बीच में ये एक intermediate की तरह काम करेगा, you can say that. And it removes the traffic, or it controls the traffic load of your BSS system. So again, it consists of EIR, sorry, equipment identity registered, which is rested with OSS system, and it is one kind of a database that contains a list of all valid mobile equipment within the network. Okay, and each mobile net station having its own mobile equipment identity, that is International Mobile Equipment Identity Number, that is IMEI number. So IMEI number marked as a invalid if it has been reported stolen or is not approved. So control operation and controlling is done by your OSS subsystem. Authentication center is responsible for authentication of your subscriber. That is, it identifies whether user is a valid user or it having a subscriber SIMs module or not. So it is also compare the secret key, or it stores the copy of secret key for authentication purpose in your SIM card. Okay, so this is all about your GSM systems, GSM architecture and their entities. Okay,